Welcome to the Lionhearted Academy. Today we're continuing our discussion in trigonometry. Today is our trigonometry lesson 50. We have been talking about solving the oblique triangle using the law of sines before. Okay, and just a quick review. The laws of sines can be summarized as the following. Is in any triangle, the sides are proportional to the sines of their opposite angles. So we have been using that proportion to help us solve an oblique triangle when we have a case 1 situation, which is when we are given one side and two angles, and case 2 situations when we are given two sides and an opposite angle. Now there are two more cases that we will need to be dealt with, but we will not be able to use law of sine to approach that. The other two cases are when we're given two sides and then the angle included between them, okay, which is the side angle side, and when we're given three sides. Okay, so those situations require us to use the law of cosine. Alright, so let's talk about laws of cosine today. So laws of cosine. So let me go ahead and summarize this very quickly. It says the laws of cosine is that it can be stated as the following: the square of any side of a triangle is equal to the sum of the squares of the two other sides minus twice the product of these two sides multiplied by the cosine of their including angle. So that sounds a mouthful, okay, but we'll go ahead and look at it in mathematical expression, and using mathematical symbols it will be a lot easier. But let's go ahead and take a look at a situation here. How does it work? So suppose we have an acute triangle. Now it works in all cases, but let's go ahead and start with this case. Okay, so this is angle A, this is angle B, and this is angle C. And remember our convention, we are labeling the opposite side, side A, to the angle A, opposite side of angle B, side B, opposite side of angle C, side C. Now the height of the triangle is in the middle right here. This is the height of the triangle. Let me use the dashed line. The height of the triangle, okay, let's call that H. So the height of a triangle is a perpendicular distance between side AB to the opposite vertex C. Okay, now let's call from A to the height, okay, let's call this distance B prime, and let's call this distance C minus B prime. Alright, so let's take a look at the situation here. Now you see in this right triangle, to the right hand side here, if we write a square, okay, this is a Pythagorean theorem, right? There's the right triangle, so we can write a Pythagorean theorem. So a square is equal to h square plus c minus b prime quantity square. Okay, so which is coming from this right triangle. Okay, and I can expand this out to become h square plus c square minus 2cb prime plus b prime square. Okay, so this is expanding c minus b prime quantity square. Alright. Now if we consider another triangle here, let me go ahead and change. Let's consider then an obtuse triangle. Okay, obtuse triangle. So this time this is A, okay, this is C, and this is B. Okay, and the height of this triangle will be coming from C down here. Hold on. The height of the triangle will be coming down from C all the way to the extension, all the way perpendicular to the extension of AB. Right? Okay, so this is the right angle. So this is your H. Alright, now this side is your A, this side is your B. Okay, and this is your RC here. This is RC here. AB is C, okay, this side is C. So let's call B prime from here all the way to here. Let's call that B prime. And let's call this, this is going to be B prime. So this extension here, little distance here is going to be B prime minus C. So based on this triangle, we can write another equation here for A squared. A squared is going to be H squared plus B prime minus C squared. Alright, and then if we expand it out, it will be H squared plus B prime squared minus 2 B prime C, which is the same as C prime B, plus C prime squared. Okay? So actually these two expressions are the same, if you notice that, because you have C squared, B prime squared, and you have minus 2C B prime. Alright, now what's another situation that's possible here? Another possibility is, let's go ahead and look at this. Let's look at the triangle ABC. That instead of angle B is an obtuse angle, what happens if angle A is an obtuse angle? Okay, so this is our angle A, angle B here, and angle C here. Alright, so this is going to be side A, side B, and this is going to be side C. Alright, so the height is going to be, this time is going to be on this side. That would be the height of the triangle, okay, extended out to perpendicular to the extension of AB. Alright, so this is your height, this is the right angle here. So this time we're gonna call still, we're gonna call this this little side extension B prime, and so the whole thing here is gonna be B prime plus C. Okay, so AB is gonna be B prime plus C. Alright, so based on this triangle, A is the hypotenuse of the big triangle right here, the whole big triangle. So A squared is going to be equal to H squared plus B prime plus C quantity squared. So H squared plus B squared, B prime squared, we're going to expand it out, plus 2C B prime plus C prime squared. No, I'm sorry, no C prime, I'm sorry, just a little C squared. To apologize here for C squared. Okay, so what do we have to do with this 3? Okay, what we're going to do is we're going to use these 3 equations. This is basically what happens is the relationship of A to H and part of the triangle here. Okay, so and this is a way that we can go ahead and do this. And try to simplify this now. Now, what is H squared? What is H? Well, H is related to B. Do you see that? If we go back to this figure 1, first figure here, B squared is equal to H squared plus B prime squared. And then here, H squared plus B prime squared is equal to B squared, and H squared plus B prime squared is equal to B squared. So that is the key. How do we set B prime, right? Some of you probably was asking us, how do you set B prime? What is B prime? Well, the key is that we, in all 3 figures, in all 3 triangles, we always set B squared. B is the hypotenuse, and H would be one leg, and B prime would be the other leg. Okay, so H squared plus B prime squared is equal to B squared. That is the key here. That is how we set B prime. And based on B prime, we can do B prime minus C here, B prime plus C here. Okay, so you can see that. Alright, so we know B squared is equal to H prime squared plus B prime squared. So we can go ahead and replace the relationship here. We can go ahead and replace one of the figure here. So H squared plus B squared, that will be B squared plus C squared minus 2CB prime. Okay, so first this 2 equation becomes this, and the third equation becomes, so equation 1, let me label that, equation 2, equation 3. So equation 1 and 2 becomes equation 4. Equation 3 becomes equation 5. A squared equal to B squared plus C squared plus 2CB prime. Okay, so there are 2 different equations here. Now, but in equation 1 and 2, okay, where it comes from, this figure, first two figures, what does B prime equal to in terms of angle A? Well, you can take a look at this. B prime is the adjacent side of angle A here. So B prime over H is equal to cosine of angle A. B prime over H is cosine of angle A. Actually, B prime over B. I'm sorry, I do apologize. B prime over B. B prime over B. H is the opposite side. B prime over B is cosine angle A in figure 1 and 2. But in figure 3 here, B prime angle A is here, right? Angle A is here. So this is the opposite angle A. Or this is the, excuse me, not the opposite of angle A, but as you can see, B prime over B is not going to be cosine A, because cosine A is the second, is in the second quadrant, is a obtuse angle. So this is the this part of the angle, which is the supplementary part of angle A, is equal to B prime over B. So that means it's going to be a negative cosine A. It's going to be a negative cosine A. The reason is, remember, cosine in the second quadrant is negative, right? So that's applied directly to that. So based on these two facts, those two equations, okay, these two equations, equation 4 will become A squared equal to B squared plus C squared minus 2C times B cosine A, so which is 2BC cosine A, because B prime is equal to B times cosine A. But in equation number 5, okay, this is equation number 5, this equation becomes A squared equal to B squared plus C squared minus, is also minus because this B prime is negative B cosine A, so it becomes also minus 2BC cosine A. So what happens is that in all three situations, our methodology will allow us to simplify the formulas down to this, and this is called the law of cosine. So yes, we went through a very complicated, a little bit of complicated process of deriving the law of cosine. Okay, so let's go ahead. Okay, I'm gonna go ahead and keep going. Let's go ahead and summarize the law of cosine. Alright, now this law of cosine would apply to all three sides. So here we're saying that this square of any side of triangle, any side. Now we're just talking about in one side right now. The square of any side of the triangle is equal to the sum of the squares of the two other sides minus twice the product of those two sides multiplied by the cosine of the included angle. See, angle A is included by B and C. Angle A is included by B and C. If you go back to the diagram here, B and C, okay, they include angle A, and B and C, they include angle A. Okay, so this is the key. Now we can replace A with the next side, which is B, and then that means we have to replace B with the next side, which is C, and C replaced with the next side, which is A. So basically it's the two other sides, and the include angle for B, A and C will be side B, angle B, and to solve for side C squared, it will be A squared plus B squared minus 2AB cosine of angle C. So these are the three equivalent formulas that you can use to solve for any given side. If you have two sides, okay, and then include the angle, you can solve for the opposite side. But based on this equation, okay, or we can also develop another set of equations here. Okay, so let's just take a look at the equation number 1, for example. A squared equal to B squared plus C squared minus 2BC cosine A. So what we can do is we can solve for cosine A. So if we solve cosine A, what we have to do is we have to move the 2BC cosine A to the opposite side, and then subtract A squared on both sides, and then divide by 2BC. So cosine A will be equal to B squared plus C squared minus A squared divided by 2BC. And then same thing here for cosine B, it will be a squared plus c squared minus b squared divided by 2ac. And cosine of angle C would be equal to a squared plus b squared minus c squared divided by 2ab. So this 6 equations, they are altogether called laws of sines, but we usually start with this, and then we can derive the cosine angle of any angle. Okay, we can find cosine of any angle given all 3 sides of the triangle. So knowing these formulas, now we can go ahead and solve our case 3 and case 4 triangles. Okay, case 3 is side, angle, side, given 2 sides and the included angle. So let's go ahead and do one example. Alright, so given let's say angle A is equal to 36 degrees and side A is equal to 16 centimeters, and I'm sorry, not side A, side B is equal to 16 centimeters, side C is equal to 20 centimeters. Okay, we want to solve triangle ABC. Alright, okay, so let's go ahead and take a look at this. Alright, so first, what do we do? Let's go ahead and draw a diagram. Alright, let's go ahead and draw a diagram. So triangle A, B, and C. Well, we don't know exactly it's going to be what kind of triangle it's going to be, so let's just go ahead and do a basic measuring. So side B is going to be 16 and side C is going to be 20 centimeters. So this has to be angle A, this has to be angle C. Alright, so first thing we can solve is, using law of cosine, we can solve this opposite sign. So a squared is going to equal to b squared plus c squared equal to 2bc, excuse me, minus 2bc times cosine of the angle A. So in this case, we don't have to do too much. We just have to substitute into the numbers into our equation here. Now, so all we have to do is just type in the calculator to calculate this exact value here. So let's do that. So here what I got is 138.2291, about 2291 for a squared. So if I go and square that, so a will be approximately 11.776 centimeters. Okay, so a is approximately 11.76 centimeters. Okay, alright, now after we get this, some people will say, oh, can you go back to use law of sine to solve for angle B and angle C, which is true, but that may not cause a problem, because angle C and angle B, one of them may be an obtuse angle, and it's obtuse if it's greater than 90 degrees, then using law of sine, it will not come up, because law of sine will only return you the angles for an acute angle in quadrant 1. So the better way to do this is still to use law of cosine. So for example, let's go ahead and solve for angle C using law of cosine, because law of cosine will always give us the right angle in the right quadrant. So let's go ahead and do that. So cosine angle C is going to be equal to a squared plus b squared minus c squared divided by 2ab. So because now we have all 3 sides, we can go ahead and just substitute them in their numbers. Okay, so what I'm going to do is, this is going to be 138, a squared is going to be 138.2291 plus b squared, which is 16 squared is 256, minus 400, okay, and divided by 2 times a was 11.76, approximately 11.76, and b was approximately b was 16. Okay, so now I actually like to use my calculator to keep those numbers as exact as possible. I don't really want to round it off, because that way it will cause some round off errors. So that means measurement angle C, it will be arc cosine arc cosine of this whole number. Okay, so let me go ahead and just type it in. So what I got is a negative 0.001534, and then it came out, once we did the arc cosine, it came out to be about 90.87, 90.88 degrees. Okay, so it's very close to 90 degrees, but a little bit more over than 90 degrees. Alright, so once we got measurement angle C is 90 degrees, then we can go ahead and solve for measurement angle B just by taking 180 degrees minus 36 degree angle A and minus 90.88 degrees in angle C. Okay, so it will came out to be about 53.12 degrees. Okay, so now we have solved all three angles. We have solved the triangle, we have found out the two missing angles, and then the missing side. So this is 53.12 degrees and 90.88 degrees. Okay, alright, so as you can see, it's not very difficult to use the formulas in Law of Cosine. But remember, if you use Law of Cosine, stay with Law of Cosine. We don't have to go back to use Law of Sine. You could in some cases if you know for sure the angle is not an obtuse angle. But I prefer to use Law of Cosine so that it will always give us the right angle, whether it's in quadrant 2 or in quadrant 1, whether it's acute or obtuse. And so please leave any questions and comments in the comment section. Please share this video with your friends or classmates, and if you have any other questions, if you'd like to know see any other videos on any particular topics that you're working with or type of problems you're working with, please leave your comments in the comment section and let me know, and then I'm more than willing to help you with some of the particular problems or other topics that I have not addressed. Alright, thank you, and then we'll continue to do more examples next lesson, and we'll move on to the last topics, finding the areas of triangle. Alright, thank you.